In this video, we're going to take a look at how we can calculate or how many sessions are supported for a transcoder, a conference bridge, or just a bearer channel termination on an iOS gateway, given the different types of PVDM3 modules that we have in the ISRG2 gateways. So there is this tool online, this DSP Calculator tool that will also give you the necessary information, a great tool to use. All you have to do is input what type of modules you have, what type of PVDM3s you have, what codecs you're going to be using, what the codec complexity is, which is something we'll talk about in this video. Typically it's going to be flex, 99.99% of the time that is, and then it will tell you how many sessions are supported, what DSPs you need for the desired number of sessions you input, etc., etc. But I'm going to go down the manual route here. So we need to have a good understanding. We can't just rely on this automated tool that will give us the necessary information. It's good to know why or how the DSP calculator tool will work. Before we get really started on the actual gateway, let's just bear in mind that each PVDM, now I'm talking all primarily about PVDM3 modules, which is in the CCI collaboration lab. It's very, very different to the PVDM2. A lot more density. The biggest technical difference is, other than scalability, is that conference bridges can share a PVDM316 with other types of media operations. So you can have a bearer channel termination and a transcoder, which you've always been able to do, but then you can also now have a conference bridge on the same DSP. So each PVDM3 module has a number of cores or DSP processors, and we'll take a look at the difference in the number of cores in each of the different types of PVDM3s that we have. Each DSP, each core, contains a certain number of credits, and those credits can be allocated by whoever's configuring the gateway to support transcoding sessions, conference bridge sessions, or just for your bearer channel termination. So I'm going to start off here at the top. We've got a PVDM316, which I like to think of as it's a half a DSP. It's got one core that supports 240 credits. Let me go on a gateway that I have. I'm on R2 right now. If I type in the command show voice DSP group all, we can see over here we've got 240 credits, and that supports 16 channels. Let's talk about how we figure that bit out. 240 credits gives us 16 channels. So I'm going to go and take a look exactly how that is the case. So given that fact, if we do some math here, we can do 240 divided by 16. So we must therefore be using or operating this calculation on the principle that every one channel, and by the way, a channel here is a call on a bearer channel using a low complexity codec, G711. Okay, so we've got 15 credits for one channel. We can look at that on the gateway, and there's a command there we can use to see that. So I'm going to do a show voice DSP capabilities. Now these PVDMs, they're inside the actual ISR, and they're in slot 0. These are the two slots that you have in the motherboard. Slot 0. In fact, let me just put the previous command in before I do that. You can see this is DSP 1. You can see right here where I'm highlighting in slot 0 we've got DSP 1. So I'm going to look at the capabilities of slot 0 DSP 1. Show voice DSP capabilities slot 0 DSP1. A lot of output there, but let's just go to the top. The bit that you're interested in is at the top. So you can see here the 240 credits. Now it's saying here G711 credits, G711 being a low complexity codec. In other words, requires the least amount of DSP resource. It's 15 credits per call. If I was to use G722, which is a very commonly used codec, that's something called medium complexity, requires a little bit more resource. That will be 20 credits. And ILBC or G729 without Annex A was 24 credits per call. And by the way, G729 with Annex A, so G729A or G729AB, Annex A and Annex B being built-in VAD, Annex A being medium complexity, that will be 20 credits. G729 without Annex A, so G729 or G729B, which is just built-in VAD, but not medium complexity, that is 24 credits per call. Our codec complexity, which is the default, is flex mode, which means that we're going to assume that every call or every call bearer channel is going to be using G711. So it allows you to max it up to 16 channels. But had I changed the complexity to, let's put medium complexity. So I'm going to go in here and go to voice card 0, codec complexity. And in fact, I'm going to, let's go with medium. Okay. If I repeat that command, repeat both commands, show voice DSP group all, you can see here the number of channels has changed to 12 now. If I repeat the show voice capabilities command, that's because it's counting every channel as utilizing 20 credits. So even if I was using G711, it will still assume it's going to be taking 20 credits. Okay, so that's why we got 12 credits. 12 channels available, because 12 times 20 is 240. So you see what the advantage of flex mode is. Flex mode is actually going to deduct the actual value. So it's going to assume that you're using G711, and that's how we get 16 channels. But if you were using G722 or some other high complexity codec, it will deduct that particular value. So flex mode uses the actual amount of credits taken by the call, whereas if you put in codec complexity medium, then it just always assumes it's going to be 20 credits, regardless of whether you're really using a medium complexity codec or indeed you're using G711. It's irrelevant. It's always going to take 20 credits per call. So if I then, for the sake of completeness, go to voice card 0 and put codec complexity high, you do the math here, 24 credits per call, 240 channels, so it's not a difficult equation to calculate. The max number of channels should be 240 divided by 24, and this will give us a value of 10 channels available. Okay, because 24 credits, high complexity mode is what I've used, 24 into 240 is 10. So if I do a show voice DSP group all, we can see here it's saying there's 10 channels as a maximum on this PVDM3 16. Now, you wouldn't need to do this unless you are sure that all your calls are going to be high complexity or medium complexity. If you have a variety of codecs, some calls are using G711, other calls are using some other codec, then you leave it to the default. So normally we do leave it as codec complexity flex mode. So the takeaway from this is, with codec complexity flex, then you will have on a PVDM3 16 or PVDM3 32 or 128, that number there in those DSPs is the number of calls supported, assuming that flex mode is being used. This isn't always the the number of cores you are supporting. You could over provision, in other words, with flex mode. So you may have to do some calculations of yourself, by yourself, if you are going to be using different types of codecs. So just because you've got a PVDM3 16 doesn't mean you can support 16 calls. It means you can support 16 calls using the low complexity codec G711 ULAW or ALAW. If you start using a different codec, then you have to either use the DSP Calculator tool or work out the math yourself. Now, I don't have a gateway that has the PVDM332, but it's very similar. It's just one core again, but this time it's supporting the full amount of credits you can support, which is 480 credits. So you can in effect support 32 calls with the caveat that all your calls are using G711 ULAW or ALAW. And a PVDM364 is two of those PVDM32s. You have two cores and you have 480 credits times 2, giving you 960 in total. So when I say number of cores, going back here, if I look at my show voice DSP group all, we would, on a PVDM364, you'd see slot 0, DSP1, and you'd see DSP2. So what you have is, in slot 0, two potential DSPs. You have two SIM slots that you put your PVDM3 module in. So the two slots, so you'll have slot 0, you have PVDM1, sorry, not PVDM, DSP1, 2, 3, 4, 5, 6. Now, in my PVDM316, I only have one core, so we're only really utilizing this. A PVDM332 would have two cores, we'd be utilizing DSP1 and 2. If I'm gonna go to another router that I have, where I've got a PVDM3 256, which is the highest density you've got. Take a look at the numbering. So do a show inventory first to see what I've got. I've got a PVDM316, and then I've also got a PVDM3 256 there, as I just mentioned. So if I do a show voice DSP group all, take a look at the numbering there. DSP1, this is my PVDM316, that's occupying DSP1, slot 0 DSP1. The next set of DSPs, look where they start, number 7. That's the start of my PVDM3 256. So what I'm saying here is, even though we're not using slot, now I don't have this is not PVDM32, so let me just correct that again. Okay, so let's go back and put that as a 2 there. What I'm saying is, we've got a PVDM316 which only has one DSP or one core, but I've got this PVDM3256 also in there. We don't start the numbering at DSP2. We are in effect reserving this block of DSPs. Even though we're using just one of the cores, we're keeping 2, 3, 4, 5, 6 numbered there but unused in case I were to remove a PVDM316 and place a PVDM3256, in which case there's 6 cores there. So the next DSP I have, we always start at 7 and we go through, so 7, can't count beyond 7 here, 7, 8, 9, 10, 11, 12. So the numbering will always start for this second DSP at number 7, regardless of what you have over here. In my case, just a 16 uses one DSP, 2 through 6 is reserved and unused in case you were to swap it out for another DSP which uses more of those DSPs. Okay, and over here, my PVDM3256 occupies DSP number 7, and there's 6 cores in a PVDM3256, so 7 through 12 will be occupied. Let's take a look at that. Okay, so there's your DSP 7 right there. If I hit or keep going down, DSP number 8, DSP 9, 10, 11, 12. Had I put the DSP inside the first position, first PVDM3 slot inside the iOS gateway. Then I would see 1 through 6 occupied, and DSP number 7 being used for the PVDM3 16 and 8 through 12 unoccupied. So that really explains the DSP numbering that we have. Alright, so we got up to PVDM3 64. Let's talk about PVDM3 128, which is slightly different, well, very different. You might think it's just 2 more cores, double what a PVDM3 64 is, but it's not. What we have is 3 cores inside a 128 channel module, and I do have a 256, which I'm going to jump on right now, which is in effect 2 of these 128. So let's just have a look at my gateway over here, and what we have in a 128 will be 3 DSPs. Here's one of them, and we've got 43 channels or 645 credits. DSP, the next one, again 43, 645, and then the third one, there's 3 in total in a 128 channel module, and although it says 645, it's not the case. 42 out of the 43 are being used, so it's slightly different there. So in effect, 43 plus 43 plus 42 is giving us our 128. So the number of credits we support, let's just do a bit of a calculation here. So I had, because it was in the second PVDM3 slot inside the gateway, so we're starting at DSP number 7, 8, and 9. We had 43 channels, 43 channels, 42 channels. That gave us 645 credits. There's channels and credits. 645, 645. This is actually a value of 630. So that gives you your 128 channels, PVDM3 128. And this is giving you, I'm going to do the math now, 645 plus 645 plus 630. Okay, so that value there gives you in total 1920 channels. So a lot of calls supported. PVDM3 256 is double that. It's 6 cores, again 43, 43, 42, times 2, so 256, and it's twice the amount of credits there as well. So if I hit return a few more times, I've talked about the first PVDM3 128 being these 3 DSPs, and now I've got 10, 11, 12. DSP 12 is the last one, and that has 42 of the 43 channels usable. DSP 11 and 10, 43 channels, 645 credits. Remember, these channels are calls, number of bearer channel you can have with G711 being used. So I think I'm going to just wrap up there in terms of the bearer channel termination, the number of channels. I'm going to just say it one more time. This is with flex mode. If you're not really using G711, then you'll have to do some math yourself and figure out exactly how many calls. Killer command for that, a really good command. Show voice capabilities slot 0. Show voice capabilities. Show voice DSP, sorry. Capabilities slot 0 DSP. Now the PVDM3 16, we covered that a bit earlier. Tells you how many cores you support there. Okay, so it's 15, 20 or 24, but it's slightly different again for the other DSPs. If I go to number 7 now, so slightly different. 15, that's the same for G711. 20 for medium complexity, that's the same, but there's another number here. It's 32 for high complexity. So slightly different values. So if I go with the number of G711 calls supported on this one core, so I'm going to look at my calculator right now, 15 credits being used, and I've got 43 channels, that gives me 645. That's how this value of 645 is given to me. If I was using all medium complexity codecs, G722 or G729 Annex A, then the value would be, so 20 credits this time, multiplied by 43 channels. That's the wrong calculation actually. That would require 860, so let's just do it slightly differently. 645 divided by 20 credits, I can support 32 medium complexity calls on this particular core. And for high complexity, if I was using ILBC for example, 645 divided by 32, I could support 20 calls, 20 ILBC calls on this particular core. Okay, that's enough about bearer channel termination. Let's go one last table to look at. So we've looked at the number of credits on a PVDM3 16. It's slightly different for a 64. So look at the medium complexity. It was 20, and for the 128 and 256, it was 20 as well. But for a 64, which I don't have, it would use 22 for a medium complexity call. Okay, and the values for high complexity are always different. So key command here to see how many calls are supported: show voice DSP capabilities slot 0 DSP whatever number is. Show voice DSP group all. And you can see exactly what DSPs are taking what positions. So I'm going to do a bit of a quiz now. On my R1 gateway, I've got this PVDM3 16, and I've got my PVDM3 256. I'm going to add a transcoder. I've got no bearer channels being used. I'm going to add a transcoder, and I'm going to find out. I want to find out how many sessions are supported. Now, there's a very easy way you can do it. Inside the transcoder, max sessions question mark, it'll tell you. But I want to really test your understanding. How do we calculate what the iOS gateway is going to give us as a max number of sessions? Okay, I've got my skinny commands in there. Let me just now add my DSP farm. So before we do anything, we always have to go to the voice card and specify this command, DSP services DSP farm. Let me also, for the time being, remove the other command. I was doing some video conferencing previously. Get rid of that. We'll come to that later on. It's saying all the DSPs are supported for voice calls. I couldn't support a video conference bridge. So we'll return to this command when we look at video conferencing in another video. So now I've got the DSP services DSP farm, which basically means these DSPs can be used for other things besides bearer channel termination. In other words, transcoding and conferencing. So now let me go in and put in DSP farm, profile 1, transcoder. And inside that, before I go on, let's see what happens. The default codec list there, take a look at it very closely. They're all, well, G711. The only codecs that are added are medium complexity codecs for very specific reasons, so you can support more transcoder sessions. So the Annex A here is very critical. This is Annex A, slightly lower quality than G729 without the Annex A, but takes fewer sessions or requires fewer credits per call. AB is even slightly worse quality than A, but it has built-in VAD, saves you on bandwidth. So let's work out with these codecs how many sessions are supported. And by the way, I have to have G711 on one side of the transcoder session, and another side can be a low bitrate codec like one of these two. If I didn't have G711 on one side, for example, I want to transcode between ILBC and G729, that's a universal transcoder, which I would add the word universal at the end, and it's not recommended you ever provision that, because you're doing you're compressing it, decompressing times 2 in that case. Alright, so back to my quiz then. How many sessions are supported here? Let's work it out. Okay, we're talking about medium complexity. So I need to find out how many credits in total there are. Okay, let's start off with the PVDM3 16 and come to the 256 in just a few moments. How many credits are consumed by a medium complexity call? MC being medium complexity. How many credits are consumed by each call? And then it will be simply this number divided by that number. So we know it's 240 credits over here on the PVDM3 16. Again, I'm going to assume that you didn't watch the previous part of this video and run through those commands again. Show voice DSP group all, and we're looking at in my PVDM3 16 240. That's in slot 0 DSP slot 0 DSP 1. So show voice DSP capability slot 0 DSP 1 gives us, for medium complexity, 20 credits per call. Let's populate those values in now. So the number of calls supported in my transcoder is 12 calls, or 12 transcoder sessions. Let's now work on the PVDM3 256. There's 6 DSPs, remember? We went through this calculation before. So we've got 645 plus 645 plus 630. And we've got 2 of those. That's the PVDM3 128. And times 2, giving us a 256. Okay, 645 plus 645 plus 630. 42, 43, 43, 42 channels. 1920 multiplied by 2 gives us 3840. So let me write that value there, 3840 credits for a medium complexity call. Let's go and have a look at that. So for DSP slot 0 DSP 7, a medium complexity call also consumes 20. So 20. So 3840 divided by 20 gives us 192 calls. That's a lot of calls. Add them together, 192 plus 12 is 204. Okay, let's have a quick look if that is the case. If this isn't 204, it means I'm just lying through my teeth to you, making it up as we go along. Feeling a bit of pressure now. Max sessions, 204. Which is great news for me, a relief. Let me now put codec G722. That should make a difference because G722 is a medium complexity codec, 204. But now I'm going to add in ILBC, or I could add in G729 without the A, Annex A at the end. This is going to make a difference. I'm going to do the same thing, but this time I'm going to have slightly different values here. I'm going to use a different color, and I'm going to use red for a high complexity call. Well, we've got the same number of credits available, so there's no need to change anything there. The only changes are here, the number of credits consumed for a high complexity call. For the PVDM3 16 module, it's consuming 24 credits, and for the 256 module, it's consuming 32. So 24 and 32 are my values here. So 24, 32, so the math's slightly different. It's 240 divided by 24, so it gives me 10 calls there. And then it's 3840 divided by 32 this time. Gives me 120, so 10 plus 120, don't need the calculator for that. 130 should be my magic number if my calculations are correct. So ILBC has made a big difference there because it's high complexity. And there's my magic number, 130. So let's just complete this table then. We've got 6 cores for 256 as we've discovered. We've got the 645, 645, 630, and we got the 645, 645, 630, giving us 3840, I think it was. PVDM3 128 is just half that. You got your 645, 645, 630, giving you 1920. More important there is the number of channels. It's easier to work with number of channels, but that's how it is right now. The 192 module, the 192 channel module, it's a bit of a hybrid between the 128 and the 64. So you've got a PVDM3 128 and 3 cores there, and then a PVDM3 64, which is 2 cores there, giving you a total of 5. So you have your 645, 645, 630, but then you've got 480 times 2. So you've got 480, 480, which is your PVDM3 64. So your total there, the number of credits there is, now I can't do that math, I'm sorry, is you got your 1920 plus 480 plus 480, giving you a grand total of 2880. Okay, and that's what you have there. Let's now switch our attention to audio conferencing, and before we talk about video, and this is actually quite easy. Before we talk about audio conferencing, let me just mention, right, let's just go with the most basic module that we have, the 16. We can put some of those 240 credits, we can allocate some credits to bearer channel termination, PRI, that we have. We can allocate some to a transcoder session, and we can allocate some to a conference bridge. So that one DSP here that we have can be split 3 ways. So that is a new feature. Back in the day, the PVDM2 module, you couldn't do that on a single DSP. You'd have to have a dedicated reserve DSP. That wouldn't be possible. You could always share between transcoder and bearer channels, voice termination. You couldn't put a conference bridge shared with either of the other 2 media resources that we have, or media types that we have. You would need to have a separate DSP for that. So I'm going to return back to my previous commands. Show voice DSP capabilities slot 0 DSP 1, which is my 16 channel. Now, we were previously looking at this line for transcoding without any encryption or authentication, any security. But for the conference bridge, we go all the way to the bottom, and you can see here the values. So it's saying for G711, the low complexity, the maximum number of parties per DSP is going to be 64. Now it's always 8 party conferences. So if there's 8 participants, we will support 8 conference bridges or 8 conference sessions. So let me just check that out. I'm going to add a DSP profile to conference, and then let's have a look at what codecs are in there right now. The transcoder above is just shut down right now, so don't worry about that. So I'm going to remove all these G729s. So that's BR8, ABR8, R8, and AR8. So right now we only have G711. You could use a software conference bridge in this instance because there's no low bitrate codec involved. And if I do a max sesh, okay, we've got 104. Let's just continue the discussion. I kind of went early there. So we can support 64 participants. I'm going to put attendees, conference attendees, over there. divided by 8 people gives us 8 conference bridge sessions. And over here on the PVDM3 256, let's take a look at that. Do show voice DSP capabilities slot 0 DSP 7. Okay, and we have 128 per DSP. So that was 128 for DSP number 7. So DSP number 7, we've got 8, 9, 10, 11, 12 involved. So we got 128 attendees or conference participants. Number 8 should be the same. I think they're all going to be the same. Again, we've got 128 there. And then number 9, which is slightly different in the case of voice termination and transcoding, but it's the same here, 128. So we've got 128 in effect times 6 is our value. Let me just get rid of that. So 128 divided by multiplied by 6 gives us a total of how many attendees? Okay, 768 in total. So we've got 768 conference participants divided by 8 people per conference. So 768 divided by 8. 96 sessions plus the 8 sessions that we had equals 104 in total. 104 conference, 8-party conference bridges with the DSPs that I have involved here. And what was that the value? Max sesh 104 is the right value. Okay, the moment I start adding another codec, let's just add G722, or let's just use the command again. Go back to the first DSP. The medium complexity codecs require there's 32 parties per DSP. Now it doesn't make a difference like it did with transcoding and voice termination. It doesn't really matter if you've got Annex A or not. There's no distinguishing between the two. All the G729s are the same. So that's 32 parties per DSP. So in effect, that's half what we had before. Okay, so I'm going to use a different color here. Okay, so for medium complexity, we've got 32 divided by 8, which is 4 sessions. And let's just make sure it's half for the 256 module. So DSP number 7. And 56 is my number. So not half. So in this case it's 56 multiplied by 6. That gives us a grand total of 336 conference participants, which in turn gives us 42 sessions. 42, so the grand total is 46. So medium complexity, okay, we're using a bit more resource. With what we have here, we have 4 on a PVDM316, 46 on a 256 channel module, gives us a grand total of 46 in there. So let's just try. Did I put the codec in there? Codec G722, max sesh 46. I can put any other G729 R8, which would be a high complexity if we're talking about transcoding and voice termination, but it doesn't make a difference to the conference bridge. However, if I put ILBC in there, that will make quite a big difference to the max number of sessions. I'm not going to run through that all over again, but let's just quickly have a look at that. All right, so my value there, it's 16. In fact, I said I wasn't going to run through it all over again, but I will very quickly do it. Different color again. So we've got 16 with ILBC divided by 8. So we've got 2 sessions here for high complexity. I'm going to write that at the bottom over here. 2 plus whatever value we have here. And what's the value for the 256 channel module? ILBC is consuming, or it requires 40, it's maximum of 40 parties per DSP. So 40, I've got 6 of those. 40 times 6 is 240. 240 divided by 8 is 30. Gives me a total of 32 8-party conferences when I've got ILBC, which is counted as a high complexity codec. Max sesh 32. If we now switch our attention to video conferencing, well, the show voice DSP commands don't show you any values for video conferencing, but we can refer to this datasheet that you'll see on cisco.com, and it's the video conferencing services for the ISR Generation 2 gateways. So down here you will see table 3 is the first one. We're going to talk about homogeneous video conferencing, and let's just take a look at a PVDM3 16. So it's saying here a PVDM3 16 supports 6 participants. So we've got 6 participants for PVDM3 16. Let's just verify that is the case. Let's go to R2 in my case. So the first thing before going to video conferencing is you need to go to the voice card and specify what percentage of the DSPs that you have you want to dedicate for voice only. Now in my case, I don't have a PRI, no bearer channel or voice termination. I have no conferencing for audio, no transcoding, so I can dedicate or provision all the DSPs for video, which is what I've done here. Okay. If you already had a PRI, then you'll see that you wouldn't be able to put 0. It will calculate how many DSPs you have or you require for the existing PRI and give you that value as a minimum. Alright, so I've already added a homogeneous video conference bridge. Let's go down and take a look at that. Okay, there is the homogeneous video conference bridge, and I'm just going to get rid of that one. And inside there, DSP form profile 1, max sessions 1. Now what I have in this gateway, if I do a show inventory, I have a single PVDM3 16. So that's allowing me to have 1 conference. So if I go inside and look at the max participants, so the values here are 4, 8 or 16. So if I up it to 8, it tells you got to shut it down. Let me shut it down. Get rid of the max sessions. 8 max sessions. Aha, 0. So this table is in fact correct. Let me go back to the web page there. It's saying 6 is the number of participants, but the only values I have are 4, 8 or 16, so not really useful to have 6. So in other words, the PVDM3 16 by itself will just support one 4-party video conference. Okay, so 6 participants, but you can only provision 4, 8 or was it 16? Yeah, 4, 8 or 16. So in other words, 1 conference call is supported on a PVDM3 16, 1 homogeneous video conference. If I go to my other gateway, R1, which has a lot more DSP resource, let's take a look at the web page, what it says regarding the 256 module. It says I can support 96. So plus the 6 we have, So we'll always have one more. Let's calculate the 256. The default is 4 parties. So this will be 24 4-party conferences plus the one on the PVDM3 16. So if I provision a video conference over here, let's just first check the voice card. Do I have all of it's dedicated for video? The transcoder is shut down. The audio conference is shut down. There's my homogeneous video conference. So if I go inside here and do a max sessions, 24 plus the one on the PVDM3 16, giving me 25. If I change that to be conference participants, and let's put 8, so now 96 divided by 8. The PVDM3 16 is not giving me anything, so it's just literally 96 divided by 8. That should be a value of 8. 12. My math is bad. 12 times 8 is 96. Okay, so this is a very useful table then for video conferencing, the number of participants. If we had a 64, then we would have, in terms of 4-party conferences, we would have 6 4-party conferences. We can up it to 8 or 16, but obviously that value, the number of max sessions, goes down. So that's your scalability for video conferencing. For hetero or video switching, heterogeneous conferencing is where you are not using, or all parties in the video conference are not using the same codec, frame rate, bit rate, resolution. So you have a mixture. In other words, it's not just video switching anymore, it's mixing as well. This will be difficult to reproduce in the lab with the 9971s and the Jabber. So in this case, I'm going to read from the table. So here it says we have 2 PVDM3 128s, supports 2 conferences. Whether it's 4, 8 or 16's irrelevant. So in other words, if you had one PVDM3 128, you could support a single heterogeneous conference. Whether it's 4, 8 or 16 parties, doesn't matter. If you have, as I've got, one PVDM3 256, that will allow you 2 sessions. Now if you put 2 of them in there, it gives you 5 4-party or 4, 8 or 16 parties. Okay. Now in my case, I've got a video conference set up for hetero. There it is. And I've put the default's 4, but it currently says 16. So if I went in there with a single PVDM3 256, give me max sessions of 2. Now if I put max conference participants 4, again, max sessions is 2, and the other option there is 8, max sessions is 2. So if I go back to this table, this is giving me the maximum values when I've got 2 of these modules inside the gateway. I think I've more or less covered the different options and the way you're going to calculate DSPs when you've got voice termination, transcoding, conferencing, and finally it was video conferencing.